In this video, we're going to determine how to write a rate law expression, determine the reaction order for the individual reactants as well as the overall reaction, and be able to determine K, which is the specific rate constant. Every rate law problem starts out with the same template of rate equals K, and then you look at your equation, or you could look at your data to determine the next aspect. It is the concentration of one of your two products. Doesn't really matter which order you put them in, but I usually put them in the order they come in. And that is going to be raised to some power, which I'm going to show you how to determine. So I've got A2 as a reactant, and it's going to be raised to a power. And also I have B2 as another reactant, and it too is going to be raised to a power. Now we're not completed yet with determining the rate law expression until we figure out what these X's and Y's are. Please notice that the products are not participating in your rate law expression, just your reactants. You have data here on your reactants. Now we're going to have to figure out what the X is and what the Y is. To figure out how A is changing, you need to find a location where A is changing, but B isn't changing. That's important because you cannot be having more than one variable when you are determining your rate law expression. If we want to see how A2 this rate is changing, I can't be looking at someplace where B2 is also changing. So it has to be stationary in the one that you choose. So I've got some changing here. I've got between 4 and 5 it doubling. Between 4 and 6 it's tripling. I prefer to look at the doubling, although you could look at the tripling. We're going to go ahead and look at the double. Notice that those two places that I picked, their B2 is constant. So we're going to look at how doubling of A affects the rate. When you say doubling of A, you use a 2. That's doubling. If I would have picked 4 and 6, I would have said a 3. But I picked 1 and 2, and that's doubling. So doubling equals, now you'll notice we're not looking at the B2 at all. We purposefully picked it to be stationary. It's not playing a role. To look to see how the rate is changing for trials 4 and 5, you take your larger of your two numbers and you divide it by the smaller of your two numbers. And when you do that, it will tell you what your difference in your rate is. So you'll notice that this one is 4 times different. So out to the side here, I'm going to do this for you. 2 equals 4. So what exponent would you have to put here in order to have 2 equal 4? And of course the answer to that question is 2. And that is why I'm going to put a 2 in this location. So I put a 2 here. That is the first part of my rate law expression completed. Now I've got to work on my how does B2 change. As you might expect, to figure out how B2 changes, I have to find a location where B changes and A stays the same. It could be double, could be triple, could be quadruple. However, I'm going to just go ahead and pick double again. It's my favorite because I know my exponents for the 2 to those pretty readily. So I've got it doubling while A is staying the same. Once again, you can't have 2 different variables. And then we're going to look to see how is the rate changing when this happens. So A is not playing a role. I say, how did I pick the change? The change I picked was double. That's why I'm using the number 2. And then it equals, what's the change here? How are 0.02 and 0.01 related, and they're related 2 times. So 2 equals 2. So then we're back over to this question. 2 equals 2 when you have what exponent? Of course, that's 2 to the 1. That's why the y exponent is going to be a 1. So our completed rate law expression is rate equals k, a2 to the 2, b2 to the 1, and that's the concentration of a2. That's what this bracket means. You say that concentration. So the concentration of a2 to the 2, the concentration of b2 to the 1. Now, it says determine the reaction order for B. The order is said ordinally. So if we want to do a complete listing, and sometimes I just talk about overall, but if you want to do a complete listing, this is second order, and second order for A2. This is first order for B2. And overall, it's third order, and that's determined by just simply adding up your 2 orders. So 2 plus 1 is how I am getting my overall order of third order. So third order overall. Those are the most common things that you will be asked about what the order is. All right, now let's determine the K, the specific rate constant. And to do that, you simply put it into your equation. However, you have to make sure you are using one of the experiments that you used in determining your rate law expression. So for this one, we can't use 3 and we can't use 6 because we never use that in determining our rate law expression. Now, possibly we could have, and if we did, maybe our rate law expression would have been different. If I would have picked something 1 and 3, I would have had a 3 here, so I would have had to look to see how those were related to figure out the exponent. So I should have had the expressions that only fit my rate law are going to be used. So you plug and chug. So we're going to go ahead and just use number 1. You can pick by looking at them. Sometimes the math is a little easier to do, picking one reaction over another. But in this problem, they look pretty well equal. So the word rate, and I go find the rate, and I plug it in. So 0.01, that's my rate, equals, K is what I'm solving for, the specific rate constant. The concentration of A2 for item number 1, the concentration of A2 is 0.001. And of course, that is raised to the 2. And then the concentration of B2 is 0.001. And that is raised to the 1. So I've got rate equals that. And just like in any Algebra 1 problem, I have to isolate K. So I've got to get K by itself. So you always ask yourself, what's keeping K from being alone? And in this problem, of course, 0.001 to the 2 and 0.001 to the 1 are keeping K from being alone. So both sides get divided by 0.001 to the 2 and 0.001 1 to the 1. Of course, on this side of the problem, those things cancel out, and k is going to be equal to, and let's talk about how to put this in your calculator, 0.01, and then you hit divided by. Now, many calculators require you to put the whole thing in parentheses because you're dividing by two things. So open up two parentheses, and then you have 0.001, and that is to the second power. That's your little caret button. And then times 0.001 to the 1. And then you have to close the parentheses that is opened over on this side. So when you do the calculations for that, you should be getting 1 times 10k equals 1 times 10 to the 7. So do your calculations and confirm that you are getting 1 times 10 to the 7. All right, I hope this helps you be able to solve a reaction, order, and rate law expression problem.